Hello, Algebra 2 students. Hope you're having a good weekend. I appreciate you finding time in your busy schedules to get your notes taken care of. As you can see from the title screen, we are getting into systems of equations for Unit 4, and that is what Unit 4 is going to be entirely about, is solving systems of equations. Now, there are different methods to go about solving equations. The first one we're going to look at is by the substitution method. We will look at some other methods as well. We're not going to look at all of them, but we'll look at the more basic ones that are out there. And we will also turn the technology loose a little bit and examine how our calculators can help us out as far as solving systems. So let's get started. Your objective for Monday will be the student will acquire a definition for systems of equations and learn to solve them by the substitution method. Copy down your objective, and again, these notes are for Monday, November the 4th. So copy the objective and put the date, and as always, press pause anytime you need more time and hit play when you're ready to move on. Okay, so the first thing we're going to do is we're going to get us a definition for system of equations. Now, you've heard it said this year already. You've probably seen it on the flashcards coming through the door. A system of equations is a situation where we have multiple equations operating in the same graph. What that means is it takes more than one equation to solve that problem. Typically, what we have happening here is we have two variables that are influencing a problem. And if we are going to accurately define what two variables are doing, then you have to have as many equations as you have variables. So if you have an x and a y in a problem, and both of them have a numerical meaning, then you're going to have two equations to describe those two variables. Similarly, if a problem had three variables, then you would have to have a minimum of three equations in order to solve it. That's the way systems of equations work. Now, what this means is for the system of equations to have a solution, okay, the graphs are going to interact with each other somehow. And we'll talk more about it, but we will have graphs that hit once. We may have graphs that hit more than once. We may have graphs that don't hit at all. Okay, but just generally speaking, wherever graphs intersect, we have solutions. In other words, there is some ordered pair, x comma y, that solves all of the equations that hit that point. Okay. What that also means is one equation will have ordered pairs all over it. Those are all solutions for that equation. The other equation will have ordered pairs, x comma y, all over it. And those are all solutions for that equation. But the system only has solutions where the graphs hit each other and they have a point in common. Now, one of the methods of determining where that intersection is located is what we're looking at today, the substitution method. As I've already said, there are other methods that are out there. I'm going to show you a couple of other methods. And again, when we've figured out how to do the math ourselves, I will show you how the calculators can help you out as well. Okay? But the substitution method is nothing more than a series of simple steps. Okay, so in order to be successful with the substitution method, we're going to have to get some steps memorized. Okay, so when solving by substitution, follow these steps. Step number one, we're going to solve either equation for either variable. Okay, you will have to make a choice. In your two equations, you will have several variables. Typically, you're going to have two x's, one in each equation, and two y's, one in each equation. You will make a decision which of those four variables looks to you like it might be the easiest one to solve for, and then we will solve for it. The second step is to substitute that value into the other equation. Once we have an equation that says something like y equals, and then you have whatever y equals, we can take whatever y equals and we're going to plug it into the other equation in place of y. The third step will be to solve for the remaining variable. In step 2, when you plugged in for the one variable, then what you just did is you eliminated that variable. It is no longer in the equation. You will have a new equation that only has one variable in it. So if we plugged in for y, then in step 3 we would be looking at an equation that only has x's, and we would solve for x. Okay. The fourth step would be to substitute the value that we just found in step 3 into the original equation we used in step 1. What this means is step 3 is actually going to bring us half of our answer. We will get a value, x equals some number, or y equals some number. That's going to be half of our solution. We're going to take that half of the solution back to the original system, and we're going to plug it back in to the same equation we messed with on step 1. The fifth and final step for the substitution method is, if I can get the screen shade to pull down, having trouble, there we go, I think. Just get it off this way, I slide it sideways, I can't seem to get it to pull down. The fifth and final step is to solve for the remaining variable. In step 4, once you plug that half of your solution into one of your first equations, you will only have one variable left. That one variable is the variable we have not found yet. It is the other half of the solution. So we're going to solve for the remaining variable. Okay, so the step 3 is going to bring you half of the answer. Step 5 is going to bring you the other half of the answer. When we put those two answers together, you will have your ordered pair. That is going to tell us exactly where the systems, the two equations in the system cross each other. Okay, so let's see if we can follow this as we work through an example. Okay, so our example is this. Okay, solve the system. And we are provided with two equations. This is what a typical system might look like. Sometimes we may see things in slope-intercept form. Sometimes we might see them in standard form. Sometimes they might not be in any particular form we know of at all. They might be all jumbled up. Okay. So what we're going to do is we're going to walk through our 5 steps, seeing if we can figure out what to do. Okay. The first step, okay, solve either equation for either variable. Now remember, we are free to pick any variable that we want from the problem. Okay, so let's look at the x and the y in the first equation and the x and the y in the second equation and decide, does any of those variables look good as far as being easy to solve? Well, yeah, actually the first equation looks very good because x is already isolated. That is a perfect situation for using the substitution method. Since x is already isolated, we already have a variable. So let's just use that one. Okay, so let's continue on. Step 2 tells us that we should substitute this value that we have into the other equation. Okay, so we have a value that we believe x equals. Okay, so let's see what we can figure out. Having all kinds of problems with my screen shade. Hold on one moment. Okay, so we're going to substitute that value into the other equation. Okay, so what we have right now is we have a belief that x is equal to y plus 5 from step 1. If x equals y plus 5, then what that means is we can take x out of the other equation and instead plug in y plus 5. And we can do this because they are equal. This is the substitution property. Okay, so our equation, our second equation, instead of being 3x plus 2y equals 5, it becomes 3 times y plus 5 and plus 2y equals 5. Now what we have successfully done is we have a new equation that no longer has two variables in it. It only has one variable, so we can solve for that variable. And that's actually the goal for step 3. We want to solve for the remaining variable. So we're going to take our equation, 3y plus 5 plus 2y equals 5, and we're going to walk through our 5 steps. Okay, parents' complaints vary for every one. Parents, that is parentheses, things like multiplication. We have a multiplication issue on the left side of the problem. The 3 needs to be distributed, so distributed. The 3 needs to multiply times the y. It also needs to multiply times the 5. So you have 3y plus 15 plus 2y equals 5. Okay, parents' complaints. Okay, complaints is for combining like terms. We have some like terms on the left side of the problem. We need to combine them. There are 3 y's and then there are 2 more y's. So how many y's is that? That would be 5. So 5y plus 15 equals 5. Okay. Parents' complaints vary. Vary stands for getting all the variables all on one side. Well, obviously, all of the y's are already together, so nothing to do there. Parents' complaints vary for every. Every stands for moving everything else the other direction. So if all the y's are going left, then everything else is going right. We need to move that plus 15. Okay, so how do you move the plus 15? We're going to subtract 15 from both sides, and that will leave you with 5y equals negative 10. Okay, and the fifth and final step, parents' complaints vary for every 1. The 1 stands for the 1 and 1 exponent and coefficient. We have 5 y's. We don't want 5, we just want 1. So how do we get the 5 to move and leave the y alone? We're going to divide it. So we divide both sides by 5, and we have a value of y equals negative 2. This is half of your solution. The y part, the ordinate of the coordinate, is going to be negative 2. Now we need to figure out what the abscissa, the x value, is going to be. Okay, so looking at step 4 says to substitute the value you just found into the original equation you used in step 1. Well, the original equation that we used was the x equals y plus 5. We didn't have to mess with it any. X was already isolated. But if we had messed with it, we would now still be going back to the original equation from the system before we messed around with it. Okay. Now we think y equals negative 2. So what we're going to do is we're going to allow y to equal negative 2 in this equation. Now, as you notice, we have only one variable left in the problem, and that variable is the part of the solution that we do not have yet. This is going to be our abscissa. So step 5 tells us that we should solve for this remaining variable. All we have to do is simplify in this case. Sometimes it won't always be that easy. You'll go back through your 5 steps again, but in this case all we have to do is take the negative 2 and the positive 5 and combine them, and that would give you positive 3. Now we have an abscissa, we have an ordinate. You put them together, we have a solution. The solution is at 3, negative 2. What that means is these two equations cross each other at 3, negative 2 in the graph. Now, I have another example for you. I want you to copy this one down and give it a try. Now, folks, some of you have been here lately not copying down your examples and things like that, and I'm telling you right now that that is going to be a reason for you to not get credit for your notes. We're going to quit doing this thing where we write down the words and just skip all of the examples, because we're not doing well enough in class to be skipping the examples. And also on problems like this where I say I want you to copy it down and I want you to give it a try, that's exactly what I'm talking about. That is going to be part of your notes. So if you copy this down and do not give it a try, that may be a reason why you do not get credit for your notes. So copy this system, look back at your 5 steps, and start walking through them. You have an example to follow for how to walk through those steps. Give it a try. Let's see what kind of a solution you can come up with, and then I will also work it out with you in class on Monday. I appreciate you finding time to do your notes. I will see you in class on Monday. Have a good and safe weekend.